Assalamualaikum. My name is Nur Atika binti Abdul Ghani. My meeting number is B0920100047. Today I would like to present about problem description. We have 6 problem description which are problem setup, static load analysis, dynamic load, result and interpretation, optimization and reporting.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Kimi bin Azhar. My message number is B0920100418. I would like to present about modeling and meshing. So we'll start the modeling. The modeling components were joined together using the boolean glue operation, create a seamless structure. Before the meshing process, the database was to preserve the progress made. To determine the components material, the preference was configured to the structure option. Based on the problem description, it was specific that the component is made to scale with the following value are yang modulus of 205 MPa and position ratio of 0.27. Lastly, they choose the element type of the option for the component were solid with 20 not 186. We received the actual model with parameter with our lecture. Then we have to construct the actual model in the ENSIF software. So we have to create 7 blocks. We continue the meshing. For the meshing, we got the select the line before performing division into block. After we select the line, then run the meshing process. For the modeling condition, point A is a fit and constraint at 0 on all degree of freedoms DOF. Force of 5 kIPS, 1.6 kIPS applied at 2 locations and 20 kIPS are applied at point B, C and D respectively. Note for force application were determined and recorded. The table shows the node number and corresponding pressure. The problem is solved using the LS option, and after that solution. That a component is displayed in figure with a red arrow representing the force and a blue arrow indicating displacement.
For the review result, the table provides the maximum stress and displacement result for the component. The values were obtained by selecting the first set of data and using the nodal solution under the plot result option. The table displays the maximum and minimum values of stress in MPa and displacement in inch. This figure represents the simulation result visual through contour plots. The plots illustrate the distribution of stress and displacement across the component. They provide a graphical representation of the component's behavior, allowing for an understanding of stress and displacement patterns. Table below present the data value for the principal stress and maximum shearing stress at point A and B. The node number, principal stress and maximum stress provide for each point. This value provide important information about the stress distribution and shearing behavior at the specific point. By referring to table and examine figure, one can gain insight into the maximum stress and displacement experienced by the component during the simulation. Then we get the time history variable and node for data type.
My name is Muhammad Hisham bin Roslan. My metric number is B0920100318. So right now I'm going to present about the discussion. There are 2 items in discussion, which is the first one is percentage of error and the second one is result accuracy enhancement. So first is the percentage of error. We have a point A, which is principal stress max. To calculate the percentage of error is theoretical minus experimental divided by theoretical times 100. So for the principal stress max is negative 0.49% of percentage of error, while the principal stress minimum is negative 0.49%. For the shearing stress is 100.20%. Next is point B. Percentage of error for principal stress maximum is negative 17.03%. For principal stress minimum is 144.12%, and for the shearing stress is 100%. So moving on to the result accuracy enhancement. First, we have a material model. Material model is a description of the mechanical behavior of a material under different loading condition. For the second one is boundary condition. Boundary conditions are the set of constraints or specification imposed on a system at its boundary or interference. This condition defines how the system interacts with its surrounding and provide information about the behavior of the system and its boundary. For the third one is mesh refinement. This involves a selective adding more elements to certain region of the mesh to capture a local variation of features of the problem more accuracy. Next is model validation. Model validation is the process of assessing the accuracy, reliability, and suitability of a model by comparing its prediction of output to real-world data or observations.